How's it going, pre-cal kids? Last time you watched a video, I did a problem where we had a point. Well, I can just go back. We did this problem, right? Where we found the 6 trig functions given a point for the terminal side of the triangle, right? Of the angle. Now, we used Pythagoras' theorem and we did all this other stuff to find it. There is a formula. Like sine is whatever your y is over your radius. Your cosine is x is over your radius. Tangent is your y over x. Okay? I never use those though, because I don't know about you, is it easier to draw a point and think about or to memorize these formulas? If you want to memorize these formulas, go for it. If you don't, you'll never have to use them. Okay? And if you didn't know, we are looking at 4.3 of B. Okay, let's talk about the unit circle. The unit circle is a circle with a radius 1. Do you guys know what unit means? Unit actually means dealing with 1. You have 1 unit, 1. The radius equal to 1. So we use this to derive our basic trig functions. Why? Because if our radius is 1, take a look at these formulas. If r is just 1, we get rid of it. R is just 1. Okay? So that tells me any point I pick, the sine of that angle is just the y value. The cosine of that angle is just the x value. And the tangent's y over x, which we're going to talk about why that's kind of tricky. So that means your x coordinate equals cosine of theta. And your y coordinate equals sine of theta. Okay? It's pretty tricky actually. That's actually amazing to think about. And tan of theta equals y over x. Okay? So, here's the unit circle. Hopefully I give this to you guys as a handout. It'll make your life a lot easier. But I'm actually going to zoom in while we do this, okay? Anyone disagree? Actually, I got an even better idea. Oh, beautiful. Okay, let's start over here. There's a dash line for degree measure and this for radian. Okay, this is thinking. It's thinking. This is 0 degrees, right? 0 degrees is the same as 0 radians. Okay, what is this point then? What's this point on? If this is an x, I'm sorry, y, x, this is a coordinate plane, that is the point 1, 0, because the radius is 1. So that means my cosine of 0 is 1. My sine is 0. Sine's my y, cosine's my x. Okay? Keep that in the back of your head. Now I go up. I go up to 30 degrees, which is pi over 6 radians. You may be saying, Mr. Wilger, how do you know so well? I've had teachers make me memorize this through the years. And you shall too. Okay, 30 degree angle. Do you guys remember when we did the 30, 60, 90 triangles? Remember this was it x? This was 2x. This was x square root of 3. So that is where we get square root of 3 over 2. Again, my adjacent or my hypotenuse. And then over here I get 1/2. So that's my cosine of 30 degrees. That's my sine of 30 degrees. Okay? Well, let's go up a little bit further. 45 degrees. Same as pi over 4. Now, again, we did this one before. That's x square root 2, right? X root 2. So that's where I get my cosine is square root 2 over 2, and my sine is the same thing. Again, guys, cosine, sine. Okay, let's move up a little bit more. Let's go to 60 degrees. Same as pi over 3. Okay. We have a half square root of 3 over 2. Now, what do you notice about the 60 and 30 degree angle? Their cosine and sines are just switched of each other. Okay, your x and y coordinate. Again, I'm going to undo this, so don't be afraid of that, Mark. If I draw this down, this is at a half. And this is at square root of 3 over 2, right? That's where these numbers are coming from. They're x, y coordinates, they're your sine, cosine, they're all sorts of good stuff. Okay, we're moving on. 90 degrees. 90 degrees is the same thing as pi over 2. Now, what's my cosine of 90? Well, look at this. What's my y coordinate? I'm sorry, what's my x? 0. So cosine 90 is 0. What's my sine of 90? It's 1. Guys, the reason why the unit circle is so helpful, because I'm going to give you a non-calculator quiz to this. It's just going to happen. And if you know how to drive your unit circle, it makes your life a whole lot easier. Okay? Now here's where I'm going to get tricky. 90, what's 90 plus 30? 120 degrees? Now, I want you to think about this one. That's pi over 3, right? I'm going to really blow your guys' minds. I'm going to draw a straight line to these two because they're kind of connected in a way. Pi over 3. This one's 2 pi over 3. Now check this out. Those are the same coordinates, just in different quadrants, right? This one I go over negative a half, but I still go up square root of 3 over 2. You see how they're kind of connected? They're the same things, just that in this one your x coordinate's negative, because it is negative over here. Okay, so your cosine's negative over here. So you have negative cosine over here, positive sine. Over here they're both positive. Okay. Now here's another crazy connection. See how these two are right across from each other? Well, this one is what's 120? It's 45. What's 45? 120 plus 50. It's 135 degrees, right? Now this one's pi over 4, right? 2 pi over 4 is pi over 2. So then we go to 3 pi over 4, right? Okay. Now with this one, it's the same point, just different quadrant. Instead of going to the right square root 2 over 2, I'm going negative square root 2 over 2. And my y is still square root 2 over 2. Again, guys, that's my sine. Okay. And we got to one more. These two kind of match up. How so? Well, this angle's 150. Again, because that's 45 plus 15, 135 plus 15. Now, this is pi over 6, right? 3 pi over 6 is what? That's not, it's 5 pi over 6. Okay. Now again, I'm just going to put a negative in front. That's just a half. So if you know this first quadrant the second quadrant, you just put negative in front of your x coordinates. Okay. It's gonna let's see. Let's keep filling this beast out. Okay. Oops. So again, this is 180 degrees, right? Because I know it's straight line across. Same as pi, because 2 pi is all the way around, half of that. What point is this on the graph? When you went over -1, you go up or down 0. Okay? So, now, okay. So now, going back to this guy. Connected him down. Well, this angle's 30 degrees plus 180, so it's 210 degrees. Oops, didn't mean to change color. That's 5 pi over 6, right? Skip 1, 7 pi over 6. Okay. Now we're still going to the right or left, -3 over 2. But now we went down, so this is -1/2. So both your sine and cosine are negative here. They're both negative. Okay. Go a little bit faster now. Connect these guys. Okay. This was 135, 210 plus 15 is 225. Okay, this was 3 pi over 4, right? So 4 pi over 4. This is 5 pi over 4. And at this angle, that was negative square root of 2 over 2. Now we're going down, so that's negative square root 2 over 2. Okay? I'm going to need to zoom. I can't zoom out. Okay, so now I'm going to connect these beasts. Okay, now 225 plus 15 is 240. That one up above was 2 pi over 3, 3 pi over 3. So this is 4 pi over 3. Up above, we had the point, we're still going to the left -1/2, but now we go down square root of 3 over 2. Okay? Okay. Here we go. This is 270 degrees. 90 plus 90 times 3 is 270. Also 3 pi over 2. What point is this on your coordinate plane? Well, you go to left, right, 0, down -1. Okay, last one. Last quadrant, I should say. In this quadrant, you'll find that cosine is positive, negative sign though. Okay. Take my green, connect these guys. 270 plus the 30 is 300 degrees. So we have 4 pi over 3, so this guy's going to be 5 pi over 3. -1/2 is now going to be +1/2 because we're going to the right. It's still going to be -3 over 2 because you're still going down. Okay? Over here. 300 plus 15 is 315. We have 5 pi over 4. So that must mean this one's 7 pi over 4. This one's your square root 2 over 2. Because you're going to the right now. You're still going down though. Okay? And connect these guys. Add 15. So that's 330. That's 7 pi over 6. And this guy is actually 11 pi over 6. because you actually go up by 5 pi, then 2 pi, then 5 pi again. Okay. So now your positive square root of 3 over 2 again, because they're going to the right. This is negative 1/2. And last but not least, you end up at 360 degrees, 2 pi, and that's where we started with. Okay. And I can actually connect those rectangles again, can't I? That is the unit circle. I had another problem. I had some other stuff to do. Maybe we'll spend some time on this tomorrow and we'll save that one for a different day. Okay?